All right, so like I said, we're going to go ahead and get started with the semester exam review. I'm going to go over all of the answers with you, so hopefully this helps. I'm going to go to my screen here. All right, so a proton, right? These are kind of mixed all together. They're not really all in order, right? Because we didn't start talking about charges until closer towards the end of the semester. So like I said, it's all kind of mixed throughout. A proton has a positive charge. So when we look at it, when we have an atom, on the inside of the atom, we have two in the nucleus. It's what's called the nucleus. On the inside of that, you have protons and you have neutrons. That's the nucleus. On the outside of that, flying around, are these electrons. And so these electrons are on the outside of this atom. So the protons are positively charged. Remember, P, positive proton, and then electrons are negatively charged and they're on the outside. Okay. A push or a pull is a force. A force, when you get something to try to change its motion, you're applying a force. And the only thing that you can do is a push or a pull. Think about that. Can you really do anything to an object other than a push or a pull? And the answer is no. All right, so if you have forces that are equal and opposite, equal and opposite, so you have two situations where they can be equal and opposite. You can have where your arrows are equal in length and opposite this way, or equal and opposite this way. Doesn't matter. They can face each other or they can face away. But if they are equal, right, equal length, then that means that the number, the size, like if this is 10 newtons, this would have to be 10 newtons. Okay. They're equal and opposite. So if they're equal, that's what's known as balance. They are balanced. What is the sum of all forces called? That's called your net force when you add everything up. Newton's blank law of motion says that every object will remain at rest or move in a straight line unless acted upon by a net force. That was Newton's first law, and we called that inertia. Newton's first law was law of inertia. Blank is the property of an object to resist its change in motion. That is inertia. Right? Resist change in motion. Well, if it resists a change in motion, that means that it wants to continue doing whatever it's doing. And so if it's continuing doing whatever it's doing, that's this right here, right? Yeah, all right, number 7, blank is a measure of the total amount of matter contained within an object. The total amount of matter is called mass. It's all of the particles of that particular object. 8, blank is a measure of the forces of the Earth's gravity on the mass of the object. So gravity is what gives us weight. We would weigh less if we were on the moon. Right? We weigh more on Earth because gravity is greater. In a blank, molecules are constantly moving, but they vibrate in a fixed location. That's a solid. They can't move around. They're stuck together. They're bonded. Number 10, a force applied over a surface. A force applied over a surface is pressure. So when you apply a force to something, you're applying pressure to it at that point of contact. Two objects with the same charge, both positive or both negative, it doesn't matter. What are they going to do if they have the same charge? There was only two things that they could do. They could either attract or repel. So if they're the same, what do? They repel each other. So if you have two positives, they're going to push each other away. If you have two negatives, they're going to push each other away. Electrons have a negative charge. We talked about that earlier. A blank is a material which heat can flow through easily. What's the material that a heat can flow through easily? It's a conductor. Conductor. Property that enables a body to do work. What allows something to do work? Energy. Something has to have energy to be able to do work. When an object gains energy because of its position, it's called potential energy, and specifically it's called gravitational potential energy, or GPE. Total energy of thermal motion of all of the particles, is called thermal energy. Thermal energy. Blank is determined by the average kinetic energy. That's temperature. So remember, motion of all of the particles is thermal energy. Average kinetic energy is temperature. Most materials will either do one of two things, expand or contract. So when things heat up, they expand. What happens to the particles as they heat up? They move faster, and they move faster and faster and faster. They move faster, and when they move faster, that causes the thing to get bigger. If you've driven in San Antonio, right, and you're crossing the bridges, you'll see those little metal pieces that go across the bridge that interlock like teeth. Those are for expansion when it heats up, because in San Antonio, in Texas, temperatures can be really hot one day and really cold one day. So what that does is it allows those bridges to expand and contract without tearing up the roads. Okay. When thermal energy flows from a hotter object to a colder object, this is called thermal transfer. Blank is the energy. The energy is called heat. The energy that flows from one object to another. When ice reaches 0 degrees Celsius, it changes state. What's that called whenever you go to 0 degrees Celsius? The freezing point. When you have ice, freezing point. When water reaches 100 degrees Celsius, what does it do? It boils. Work can be calculated from the equation work equals force times distance. right? You have to apply a force to an object. As you apply that force, push it over a certain distance. That's called work. Remember, if the object didn't move, then no work was done. Distance and direction through an object moves is the displacement. I thought I got rid of that. If the force and movement are in the same direction, the work is positive. You're doing positive work. Blank is the form of energy stored. If it is stored for later use, it's potential energy, like a battery, right? A battery has potential energy. Blank is the energy of motion. It's kinetic energy. Kinetic energy depends upon, well, two things. If we look at the equation, kinetic energy is mass times velocity squared over 2. What two things do we have in our equation? We have mass and we have velocity. Since mass is not in here, the only other thing we can pick is velocity. When heat is added to gas in a cylinder, the gas will do what? Well, what did we just say happens to things when they heat up? They expand. Exactly, they expand. So the gas is going to expand. Things, the molecules move faster, and so it expands. Collection of blank creates an electric field. Well, work is when we apply a force to something over time. Energy is if we can do work, and a book has nothing to do with anything that we're talking about, right? So what's the only thing that creates an electric field? The only thing that we've ever talked about with electricity are charges. Blanks are a source of potential energy. So I gave you the example early on when we first started talking about potential energy, and I said a battery has the potential energy in it. If you set it there, it doesn't do anything, but you could use it later on. It would be a battery. Rate at which charges flow, that's current. Think of flow like a river flows, water flows through the riverbed. Well, if you have charges that flow, that's called current. Not all electrical work is converted to mechanical work. Where do we lose energy ever? And it's because of friction. Friction always produces what? What does friction always produce? Start with an H. Heat. So it's because of this heat loss or this thermal energy of loss that nothing can go forever. It's because heat is always, always, always lost. You can't ever get it back, right? When you have your car or you're driving in a car and the engine heats up, right? That heat is energy. But how can you use that heat when it's just coming off the hood of your car? You can't, right? It's wasted energy. All right, speed at any one instant is called instantaneous speed. Speed and direction is velocity. Right? If it's just the speed, then we call it speed. Vector, I thought I got rid of this. Two positions is called displacement. Transfer of thermal energy arising from a temperature difference is called between objects next to each other. So if you have objects that are next to each other, I thought that I put in touch in this, maybe not read that version. If they're next to each other, what I really wanted to put on there was where they were in contact or when they were touching each other. So if you have two objects, we'll call this one a hot object and this one's a cold one. So energy goes from hot to cold. So if they're in contact with each other, they're next to each other, if they're touching, what do we call that? We call that conduction. Blank is a transfer of heat by movement of a fluid. For a fluid, we said we call it convection. And convection currents could occur where hot would rise and cold would sink, right? In the air, hot air rises, cold air sinks. It's the reason why we have weather. What type of energy does a nuclear power plant produce? What type of energy does a nuclear power plant produce? All of the plants, everything that we've talked about, when we talked about energy sources, always produced electrical energy. What's the biggest problems faced with fossil fuels? That's pollution. Trying to figure out a way to reduce pollution. What about the biggest problem with windmills? Windmills can kill birds, right? It can cause their migratory patterns to be altered, which can change an ecosystem. What are energy sources that can be used over and over or replenished rapidly? Those are renewable resources. What is the object called that can turn with wind, air, or steam, and it turns a generator to produce electricity? That's called a turbine. What does not allow heat to flow through it easily? That's an insulator. When you wear a coat in the winter, the material is an insulator, right? Usually it has wool or feathers or has a lot of air because it insulates you. It keeps you warm because it does not allow heat to flow through it easily. It slows it down. Okay. That's why your coats and sweatshirts are not made out of metallic materials. What is the overall charge if there are more protons than electrons? Well, let's say that I have 3 protons and 2 electrons. The positive is protons. So if I have more protons, what's the overall charge going to be? Positive. Right? It's going to be positive because I have more positive. All right, just a few more. Car travels 50 miles per hour in 3 hours. Calculate the distance. So distance, you'll have this distance from a triangle. Let's show a triangle. Distance is on top, velocity is in the lower left-hand corner, time is in the lower right-hand corner. Cover up distance, I'm left with velocity times time. So distance equals velocity times time. Here's the velocity, 50 miles per hour. The time is 3 hours. So if I calculate that, that ends up being 150. Everyone good on that? You will have the triangles on your exam. All right, couple more. Calculate gravitational potential energy. GPE is equal to mass times gravity times height. Here's the mass, it's 5 kilograms. Gravity is 9.8, and the height is 10 meters. So we want to pick the one that when we multiply all three of this will give us the correct energy. So if I multiply all of these together, I'm going to get 490. Look, 490. Calculate kinetic energy. Kinetic energy is mass times velocity squared over 2. The mass is 2,000, so it'd be 2,000. The velocity is 30, so don't forget to square that, and that's over 2. So we plug it in on the calculator, it would be like this. 30, here's the square button over here by the 7. Push that. So 30 squared, I'm going to press enter. I'm going to multiply by 2,000, enter, divided by 2, enter, is 900,000. Go. Calculate momentum. Momentum is just simply mass times velocity. So if the mass is 2,000, the velocity is 30. To calculate the momentum, you're just going to multiply those two things. So you're going to do 2,000 times 30, and you get 60,000. Look, 60,000. And the last one says calculate the speed or velocity. That's distance divided by time. The distance is 100 miles. The time is 2 hours. So you're going to get 50 miles per hour. Right? Does anybody have a question on any of that?